All right, so in 5.6, we have a plane taking off from an aircraft carrier. And they're asking us if this is the average force, what is the mass of the jet? And they gave us the change in velocity or change in speed of the aircraft and the amount of time it took. So this is one of the ones where you could do just a force diagram, or you could do a force diagram with a little bit of verbiage, a little bit of writing. I think probably a little bit of writing, but mainly a force diagram on this one. I'm actually going to use this one form for it. So 5.6, and really the only words I need in here is to explain that I understand what acceleration is. So, you know, that it's something along the lines of acceleration, rate, that velocity is changing. The main part, therefore, would be a force diagram. Draw some type of planey looking thing, and it's going to have a force in this direction on it, and that is causing an acceleration in that direction. So, not really a complicated force diagram, but mathematically now, are any questions on that before we do the math involved? All right, so mathematically, I'm going to use my definition of acceleration, really weird A, which is that A is delta V over delta T, and I'm also going to use Newton's second law. These should all have vector symbols on them. I only have one force, so that's kind of convenient. And I'm just going to combine these two now. So my total force is my mass times my change in velocity over change in time. So mass V final minus V initial over change in time. I'm looking for mass, so I might at this point even rearrange this for mass, right? Because that's what I know I'm looking for. So I have F delta T over V final minus V initial equals mass. So I'm ready now to put some values in here. So looking at my values, let's see. They tell me my force 9.2 times 10 to the 5th newtons, and that's a base unit, so that's good. They tell me my time 2.0 seconds, base unit again, good. They tell me my initial velocity 0. And they tell me my final velocity 240 kilometers an hour. Kilometers an hour, I should probably convert that to meters per second. Or convert my time to hours and convert my newtons to kilogram kilometer per hour squared, which would be kind of weird. So I think it'll be easier to convert one value rather than two values. Yes? No? Okay. So 240 kilometers an hour. I'll do this over on the side here. So and I can either do that by hand by multiplying by the number 1 twice, or I could go and look it up online, or I could use my calculator. You guys know how to use your calculator to do conversions? No? Do you care to learn how to use your calculator to do conversions? Sure. Okay. And we'll use our calculator. So the part, where you want to go in your TI is go to apps. So there's an apps button right next to your math button. And depending upon whether or not you've cleared your memory, you should have a bunch of applications there. If you don't, then you might want to hook it up to a computer and download them. The one I'm going to look for is called SciTools. And I'm just arrowing up. Maybe easier for you to arrow down since I have a virtual one. They throw all of the possible apps on here. And there's all sorts of. So I'm looking for SciTools. There it is in French. There it is in Spanish. There it is in English. So once you find SciTools, you hit enter, select it, and then any key. And then you have 4 different parts of science tools here. The one we're looking for is number 2, unit converter. And I'm given all of these choices. I'm looking to convert velocity. So I'm going to pick number 6. And what I do is I put in what I have. So I have 240. And then I arrow to the units I have it in. Mine, I'm picking kilometers per hour. I hit enter. And so I put in the value. There you go. Of 240 kilometers an hour. And here's the part that's not really clear on the screen. Then I arrow to what I want. The arrows are, oops, I must have hit it twice. 240 kilometers an hour. Then I arrow to what I want, in this case, meters per second. And I hit enter, and it converts it to meters per second. So mine tells me, now be careful, it's in scientific notation. So mine says 6.666 repeating times 10 to the first. Yeah. Oh yeah, yeah. Times 10 to the first. So mine is 66.667 meters per second. So you got to be careful since it's in scientific notation to not drop that. Any questions on how to do that? You, of course, could also just throw the number into Google. And Google has a nice converter in it and things like that. Or you could have done it by hand, as you've done probably countless times before. But I'm just quitting out of there and exiting. There we go. All right, so I'm ready now to put in all my numbers. The force they give me, 900. So 9.20 times 10 to the 5th newtons, 2.00 seconds, all over my V final, 66.67 meters per second minus 0 equals M. And when I finally get that M out, it's going to be in kilograms. Right? I've kept all my units to the base as we've gone along. So, good? Any questions on that one before we jump into another one? Alrighty. All right. So, rocket height. Now, this one is one that you could do a force diagram for on top of your written Y. I'm actually just going to do a couple of little pictures to remind myself that at the beginning point, it's accelerating, and then at upwards, and then after the fuel's exhausted, which way is it accelerating? Huh? It's still moving upwards, but which way is it accelerating? Downwards, because it's in free fall. We know that everything accelerates down at little g when we're in free fall. And then its maximum height, what do we know is special about its maximum height? It's only true at its maximum height. It's not moving. Its velocity is going to be 0. That's the special condition of its maximum height. So I'm going to express these things in my Y that it accelerates upwards at beginning. So increases speed upward. Maybe when in free fall, the acceleration is down, and then maybe at top, the rocket stops. The other might also include in there when is it going to be moving the fastest? When is it going to have the highest speed? When do you think? When during that portion? Yeah, well, we have 5 seconds then. At the beginning of that, in the middle somewhere, at the end of it, where in there do you think? At the end of the 5 seconds, yeah, I agree. Because the whole time during that 5 seconds, it's gaining and gaining and gaining more speed because its acceleration and its velocity are in the same direction. So at the end of that time, it's going to be at its highest speed. And then after that, the acceleration flips to downward and starts slowing down until it eventually stops. So I might show that in that'd be a great understanding to have in your Y, max, something like max speed at end of 5 seconds. And what I'm going to draw here, I'm going to draw the path of this rocket like this, and I'm going to color code it for myself. During the red, it's accelerating upwards. And then as we said right here, that's where the max speed is. And that's up. During the green, its acceleration is equal to little g, and it's downwards. And then at the top, I'm going to put v equals 0. That'll be my top. And this whole thing is my height. That both those segments together. I need to treat these mathematically. I'm going to treat these as separate segments, and then add them together to get my total height. So let's say height-wise here, where do you guys want to call 0 height? I'd suggest either the ground or the top. Ground, okay. So we're gonna call at the ground 0 meters. We'll call right here, how about distance, and we'll call it d sub a. We'll call that point the location where it stops accelerating, so d sub a. All right, and then we're already calling the top h, right? We can call this point up here h, and that'll be the total height it gets to. So from 0 to d sub a, it's going to be accelerating upwards. And then for the second portion, it's going to be accelerating downwards. And we know that at the top, its velocity is 0. Right? So, let's see. And they just want to know the height, right? Maximum height. Okay. And they tell us the time here, call that delta TA, they tell us is 5 seconds, right? All right. So my approach is going to be I want to find everything out that I can about this red segment, and then so I should be able to find out how high it is at the end of it and how fast it's going at the end of it. And then once I find out everything I can about the red segment, I'm going to find out what I can about the green segment. And that will, then I'll know what h is from that green segment by combining it. So, start off with the red segment. I'm going to use d equals d naught plus v initial t plus 1/2 a, sorry, delta t squared, and that should be delta t. And little vector symbols. There we go. So it's gonna, remember this is about where the positions I end up, start in, and how much I move because of all these other factors. So I end up at a height of d sub a. I start at a height of 0 meters. My initial velocity is 0. My time is 5 seconds. My acceleration, which way do we want to call positive? Up, okay. I kind of assumed that because I called it d sub a, right? So we'll call up positive. So I'm accelerating up. I think my number was 44.1. 44.1 meters per second squared. And then 5 seconds squared. So I can, all numbers except for d sub a. So I can, yay, that makes life happy. Let's see, 0 times 5, 0, right? Okay, so 0.5 times 44.1 times 5 squared, and that gives me 500. So at the end of my red segment here, I'm up at 551.25 meters. I'd like to know how fast I'm going at that time. So for that, I'm going to use V final equals V initial plus A delta T. V final will be my max speed there. I don't know what that is, so I'm going to call it VA for the velocity at that point where the acceleration ends. I know my V initial, it's 0. My acceleration is 44.1 meters per second squared. My time is 5 seconds. The velocity at A I get 220.5 meters per second. Pretty fast, right? So now, I think I know everything about this red segment that I can know. I know the time it takes, I know its acceleration, I know how far it is, I know my speed at the beginning, my speed at the end, or my velocity at the beginning, velocity at the end. So now I'm going to investigate this green section. I know where the green section starts. I know how fast the rocket is moving at the beginning of it. I know how fast the rocket is moving at the end of it. I know the acceleration. And so I want to find out what's h? Oh, I have another equation that I haven't used yet. For my equation sheet, I have v final squared equals v initial squared plus 2a delta d. I could also have gone the way of finding the time and figure out, the distance. I'm going to go this way instead. And you can do one expansion on it just to help myself out. 2a d final minus d initial. My velocity final is 0, because that's how fast it is at the top. My velocity initial is 220. Actually, let's rearrange first, sorry. I care about df, which is going to be my height. So I'm going to have v final squared minus v initial squared equals 2a df minus di. Rearrange that. And now I'm going to substitute in 0 squared minus, what was it, 220.5 meters per second squared over 2 times 9.80 meters per second squared. My acceleration is g, right? Little g. That equals, my final location is h. My starting location is where I was at the top of the red segment, which we found to be 551.25 meters. And solve for each. Let's see. Because it's in free fall, and the acceleration of anything in free fall is 9.8 meters per second. Remember, in that second segment, that blue segment, it was the acceleration is little g. Yeah, that's this one. You got it? So, So I get 3030 meters. Seems to make sense because before it was accelerating at 45, which is like 5 times, no, 4 times, yeah, about 4 or 5 times acceleration of gravity, and it took about 4 or 5 times longer to go from that speed to 0. So let's see. All right, so in this one, we're going to look at the clear the runway problem, which has, what, 3 or 4 sections to it? 5, maybe? You guys notice I gave more points for these? Say had more sections? Yeah, okay. Seeing the little things I do, if you guys notice them. So, all of these go back to, this one would not necessarily need a force diagram. Might be helpful, but you wouldn't necessarily need one on this. It's really about understanding how acceleration is related to different parts of the motion. So in my Y, clear runway, I'm going to focus on showing that I understand that acceleration is the rate the velocity changes, and this influences, how about, the speed and location. So, just you're trying to show you understand that all of those are connected to each other. Looking at the problem, you might also think about, okay, A is kind of general about the whole thing. I saw a pen in my hand. B is about the end. C is about the beginning. D is about the end. And one thing the problem is trying to get you to realize is that it's going to move a lot further in the last second than in the first second, because its average velocity, its velocity at the beginning and the end, are much higher than its beginning and the end of the beginning section. So, and then part E, it's asking you about what percentage of takeoff loss. So that's another way to think about it. So we look at, do we want to just work through this, or were there specific sections that the people asked for had more difficulty with? Okay, so we'll just work through it. That's fine. I didn't want to spend 5 minutes on A and then have the A with nothing. All right, so constant rate, 1,800 meters long. Assume the plane reached takeoff velocity, what is the time TO needed to take off? All right, so I'm going to start off with A. We're going to use D equals D naught plus V initial delta T plus 1/2 A delta T squared. You guys okay with calling down the runway positive and the beginning of the runway 0? Okay, so it's going to end up at 1,800 meters. It started at 0 meters. Its initial velocity was 0. Its time is what we're looking for. So delta T plus 1/2, is that 5? 5 meters per second squared, delta T squared. So I'm left with 1,800 meters equals 2.5 meters per second squared, delta T squared. solve for delta T. So I get 26.8 seconds. And I should probably check that, but call it good. Part B, what is the speed of the plane as it takes off? And so for B, I'm going to use V final equals V initial plus AT, A delta T, excuse me. I'm looking for V final. V initial is 0. 5 meters per second squared. Delta T, I'm going to use my whole delta T, 83 seconds. So that's one of the nice things about using the TI. I can now just turn around times 5. And I get 134 meters per second. Parts, slow me down or stop me if I'm buzzing by it way too fast, okay? What is the distance traveled by the plane in the first second of its run? All right. So I'm going to go back to my D equals D naught plus V initial delta T plus 1/2 A delta T squared. And I'm looking for how far it went. Started at 0, meet 0. The initial velocity was 0. Time is 1 second. Plus 1/2. 5 meters per second squared. 1 second squared. 2.50 meters. Right? On to part D. What distance traveled by the plane the last second before takeoff? Okay. So what I'm going to do for D is I'm going to use the same equation. But I'm going to need, if I use the same equation, I need a V initial. And let's see what information I have. I have the V final, right? And I have the time. So what I need is a V initial for that segment. And I'm going to use a little bit of logic here. If it's going 134 at the end, and its acceleration is 5 meters per second, that means every second it's gaining 5 meters per second. So how fast is it going 1 second before the end? 129, 5 meters per second less than that. So I'm going to use that. You could do that also. In fact, why don't I do it for those playing along at home? But I know the answer already. V final, V initial plus A delta T. I know the V final is going to be my 134. I don't know my V initial. I know this is 5 meters per second squared. This is 1 second. And so I get V initial as 129. I'm just going to look at my calculator. 129.164 meters per second. Now I can use that D equals D naught plus V initial T plus 1/2 AT squared with all the deltas in there. I know I end up at 1,800 meters. That's the end of the runway. This is where I begin. My V initial now is 129. And I knew I was around time. All right, make sure you have the tasks for Thursday.